Good morning, boys and girls.
Today we are going to do lesson 14-2, patterns, number rules. I can use a rule to extend a number pattern, identify features of the number pattern, and use the number pattern to solve a problem.
Let's get started. There are 6 juice boxes in one pack, 12 in 2 packs, and 18 in 3 packs. How many juice boxes are in 4 packs? In 5 packs? In 6 packs? Use the rule to complete the table. Describe the features of the pattern. Then find how many juice boxes are in 10 packs and 100 packs. Ms. Schultz, what do we need to find here?
So I need to find how many juice boxes are in 4 packs, 5 packs, and 6 packs. So I need to complete the table. Then I need to describe a feature of that pattern. And then I need to find how many juice boxes are in 10 packs and in 100 packs.
Looks like a lot of work. What do we know already?
Well, I know that in 1 pack of juice, there are 6 juice boxes. In 2 packs of juice, there are 12 juice boxes, and in 3 packs of juice, there are 18 juice boxes.
Okay, so let's see if we can find out how to figure this out by looking at the table. What relationship is there between the number of packs and the number of juice boxes?
So I'm noticing that the table is giving us a rule, and the rule says that we need to multiply by 6. So it looks like we're going to multiply the number of packs by 6. And Mr. Rivera is reminding us that a rule is a mathematical phrase that tells how numbers or shapes in a pattern are related. The rule for the numbers is this multiplied by 6.
Perfect. So why don't we add that into our chart? Like we could add times 6, times 6, times 6, and that could help us solve.
Perfect.
So if we replace it with this table, we can just fit the numbers in. We already have 1 times 6 is
6.
2 times 6 is
12.
3 times 6 is
18.
4 times 6 is
24.
5 times 6 is
30.
6 times 6 is
36.
Beautiful. So we've just completed our table.
Yeah. So in 4 packs of juice, there are 24 juice boxes. In 5 packs of juice, there are 30 juice boxes. And in 6 packs of juice, there are 36 juice boxes.
Wow. Can we look at these numbers to find a feature of this pattern?
So since we're multiplying by 6 as our rule, I can tell that one of the features is that all of these number of juice boxes are multiples of 6. 6, 12, 18, 24, 30, 36.
Great job.
So now we need to determine how many juice boxes are in 10 packs and how many juice boxes are in 100 packs. So we have to use the same rule as we did before. So if there are 10 packs of juice and we multiply it by 6, there should be 60 juice boxes.
Perfect. What about 100?
100 packs, we multiply that by 6, that's going to give us 600 juice boxes.
So we know that the number of juice boxes are multiples of 6, and they also all happen to be even numbers as well.
Yep, that's another piece.
10 packs will have 60 juice boxes, and 100 packs will have 600 juice boxes.
Great.
Let's try another one. There are 3 leaflets on 1 clover leaf. There are 6 leaflets on 2 clover leaves. There are 9 leaflets on 3 clover leaves. How many leaflets are on 4 clover leaves? How many clover leaves will have 12 leaflets? That one's reversed, the last question, looks like.
Yes. Okay, so they're asking us for 2 things here. So the first thing that I need to find is I need to find how many leaflets are on 4 clover leaves. And the second thing I need to find is how many clover leaves will have will have 12 leaflets.
Perfect. What do we already know?
So I know that there are 3 leaflets on 1 clover leaf, and there are 6 leaflets on 2 clover leaves, and 9 leaflets on 3 clover leaves. Let's use a table to create, extend, and identify features of this pattern.
Perfect. So I see on our first table, we're looking at a rule multiplied by 3, and this is going to help us find out how many leaflets are on 4 clover leaves.
Perfect. So the rule says multiply by 3. So if I multiply 1 clover leaf by 3, then there will be 3 leaflets. If I multiply 2 clover leaves by 3, then there'll be 6 leaflets. And if I multiply 3 clover leaves by 3, there'll be 9. So if I multiply 4 clover leaves by 3, that will give us 12 leaflets.
Great job. Let's look at the next table. This is giving us a different rule, to divide by 3, because now we're looking for the number of clover leaves instead of the number of leaflets. So
Right.
How many clover leaves for 12 leaflets?
Okay, so if I have 3 leaflets, I have to divide by 3 and I'll have 1 clover leaf. If I have 6 leaflets, I need to divide by 3. That will give me 2 clover leaves. And 9 leaflets divided by 3 will give me 3 clover leaves. So if I have 12 leaflets and I divide it by 3, I'm going to have 4 clover leaves. And if you notice, Ms. Ortiz, we're using inverse operations here. When we wanted to find the number of leaflets, we multiplied the number of clover leaves by 3 to find the leaflets. But then when we wanted to know how many clover leaves there was, the opposite, when we wanted to find the opposite, we did the inverse operation.
It was like flipped.
Yep, to find the number of clover leaves, we had to divide the number of leaflets by 3.
Perfect. So we can think about feature of this pattern.
So I would say a feature of this pattern is all of the numbers are multiples of 3, or I should say in the first pattern where it's the first rule multiply by 3, all of those number of leaflets are multiples of 3. 3, 6, 9, 12.
Great.
However, in the second pattern where we had to divide by 3, I'm noticing that in the pattern number of clover leaves, it's increasing by 1. So 1, 2, 3, 4, and the pattern's increasing.
Yeah, great job. Let's take a look at the next one. Complete the table. Describe a feature of the pattern. So I see that this is giving us a rule, divide by 4, and we're talking about the total number of wheels on the number of cars. So what do we need to find here?
So I need to find the total, the number of cars that have 20 wheels.
Perfect. What do we know?
Well, I know that if I have 8 wheels, I have 2 cars. I know that if I have 12 wheels, I have 3 cars. And if I have 16 wheels, I have 4 cars. And the way that I determined that was to divide the number of wheels by the number of cars.
Perfect. Like that's how we can find the relationship between 8 and 2, 12 and 3, 16 and 4. And then we'll find 20 and its partner.
Great. So to find the number of, so we did 8 divided by 4 to see the relationship between 8 and 2. 12 divided by 4 to find the relationship between 12 wheels and 3 cars. 16 divided by 4 to find the relationship between wheels and 4 cars. And then the last one will be 20 divided by 4. If we have 20 wheels and one car has 4 wheels, we should have 5 cars.
Great job. I'm just going to put that up in there.
So if you have 20 wheels, you have 5 cars.
Let's take a look at the next one. How many more batteries do 6 flashlights need than 4 flashlights? Explain. So I'm noticing our little friend here has a table that's talking about batteries for flashlights. The number of flashlights, and the number of batteries. So I can see that he's talking about one flashlight needs 3 batteries and so on. So what is this question asking us to find?
So we need to find how many more batteries do 6 flashlights need than 4 flashlights.
Great. What do we know already?
Well, I know that 1 flashlight needs 3 batteries, 2 flashlights need 6 batteries, and 3 flashlights need 9 batteries.
So it looks like Mr. Rivera is trying to help us figure out the rule and get the relationship between, let's look at the first 2 numbers, 1 and 3. So if we start out with 1, how can we get to 3?
We can add 3, but if we add 3, is that going to work for 2?
Well, if we start at 2, how did we get to 6? If we do 2 plus 3, that would be 5.
So that can't work. So our rule cannot be add 3. So how else can we get from 1 to 3? We could multiply.
Yeah, multiply by 3. 1 times 3 equals 3. Let's check for 2. Would that work? 2 times 3 equals 6.
Yep.
And let's double check with the last one. 3 times 3 equals
9.
9.
So that works. So it looks like our rule is going to be multiply the number of flashlights by 3 to find the number of batteries.
So we have the
Okay,
number of flashlights.
Great.
Okay.
Now we have to figure out how many batteries are needed for 4 flashlights, 5 flashlights, and 6 flashlights. Then once we find that, we can determine how many more flashlights are needed for 6, how many more batteries are needed, for 6 flashlights than 4. So let's multiply 4 by 3. That's going to give us 12. So we'll need 12 batteries for 4 flashlights. 5 times 3 is 15. So 15 batteries. And 6 times 3 is 18.
Perfect. Are we done now?
Not yet. Now we have to figure out how many more batteries are needed for 6 flashlights than 4 flashlights. And I know when I have to compare numbers, I need to use subtraction.
Yeah, because we're asking to find how many more.
Yep.
So which number will we use first?
So let's take the greater number, which is 18 batteries for 6 flashlights, and subtract 12 batteries for 4 flashlights. So now we can do 8 minus 2, which is going to give us 6, and 1 minus 1 is 0. So 6 more batteries are needed because 6 times 3 is 18, 4 times 3 is 12, and 18 minus 12 equals 6.
Great job. That's how we can use our rules with our table and data to extend the number pattern and find different features of that pattern.
See you next time.